In this second video dealing with calculations using Faraday's law of electrolysis, we're going to look at one situation, and then we're just going to slightly change that situation and see what the effect is on the subsequent calculation. So we might as well get started. So here's the question: what current in amperes, so we're looking for a different variable here, what current in amperes must be applied to a solution of iron 3, so that's Fe 3 plus is what we're looking at there, if this current yielded 5 grams of solid after 25 minutes. So again, in terms of variables, we're looking for current, but we're given a mass of iron, and so that's going to allow us to find charge, and we're given the time, t. So again, like I mentioned before, there's 3 variables of interest typically. We know 2 of them. So first step would be number of moles of iron equals mass divided by molar mass, 5.00 grams divided by 56.85 grams per mole mass of iron. And so we number crunch that one, we get 0.0880 moles of iron. Now the half reaction we're looking at here, this is iron 3, so it's Fe 3 plus aqueous plus 3 electrons yielding Fe solid. And so in terms of moles of electrons, it's going to be 0.0880 moles of iron times our equation factor, which is 3 moles of electrons over 1 mole of iron. And so we get 0.264 moles of electrons. So there's moles of electrons. Now we can calculate Q. So Q is the total charge, and that equals the number of moles of electrons multiplied by the Faraday constant. That's 0.264 moles of electrons times, there's the Faraday constant up top, 96,485 coulombs per mole. Moles divide out, and you're left with a total charge of 25,457 coulombs. Okay, so we're almost there. So now we have charge. We were asked for the current I. So current I equals total charge divided by time. Total charge we just calculated is 25,457 coulombs. Our time was 25 minutes, but we need to convert that to seconds because the unit ampere is coulombs per second. So we're going to multiply that 25 minutes by 60 seconds per 1 minute. And so when we do that, we get a current of 17 coulombs per second, or 17 amperes. So there we go. If we apply that current, if we apply this current, 17 amperes, for 25 minutes, we would produce that 5 grams of iron solid. So that's fairly straightforward, a typical sort of Faraday's law of electrolysis type question, having to find the current given the mass and the time. Okay, so we're going to switch it up a little bit here, and so what would be, would the same current, that is the current we just determined, 17 amperes, applied to a sample of iron 2 for the same period of time, produce the same mass of iron? So that's the question you're going to try to answer, and you need to justify that, and you need to be able to explain it. So here we go, let's get going. And that concludes this video.